Welcome to lecture 21 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. In this lecture we will look at the basic GUI components. The agenda of the lecture consists of basic GUI programming concepts, graphical user interface that is, simple GUI based input output, JFrame, JPanel, JLabel using layout managers, custom painting and graphics. We will try to cover as much as we can in this lecture and continue our discussion of graphical user interface in the upcoming lectures. The relevant material for this lecture can be found in chapter 12 of the reference book, and you can also find other tutorials that can be useful on the given links. A graphical user interface presents a user-friendly mechanism for interacting with an application. For example, you provide an input to application, it provides you the output on the screen, pronounced as GUI, gives an application a distinctive look and feel. Up until now, we have been working with the console-based programming, and some of the students were complaining that we have only been printing values on the black screen or the white screen. But in graphical user interfaces, what we can do is we can see things and we can do things on the screen. For example, we can click a button and we can see the real-time response of that button or clicking the button. In the conventional programming, sequence of operations is determined by the program. So we write the program and we can only get the output in the sequence in, let's say, console-based programming that we have already provided. For example, we can only print in a certain order, in the order that we have used in our program in advance. What you want to happens when you want it. So we can only, for example, print something wherever we use the print statement. So we can only decide in advance that where a certain action should happen or where a certain method is called, and things will happen in that sequence. Event-driven programming or the graphical user interface programming, the user inputs through some widgets and the application, for example, provides us the results. Sequence of operations is determined by the user's interaction with the application's interface. So you can click anywhere on the screen and you can get the results. It's not like you will have to wait for a certain sequence to get your result. Anything that can happen happens at any time. So you can click on a certain gadget at any time and you can get your result. Or you can, for example, if it's a drawing application, you can draw over the screen at any position. So this is the difference between our conventional programming, which was console based programming, and event driven or the GUI based programming. That in the GUI base we have an interface and we are maybe allowed to click anywhere on the interface and get our results instantly, as against the sequence based results that we get through the console based programs. Implementing GUIs in Java, the Java foundation classes, let's say JFC, are a set of packages encompassing the following APIs. For example, we have the AWT, the Abstract Windows Toolkit API that contains packages related to graphical user interface programming. The older version of the components rely on pair architecture drawing done by the OS platform on which the application applet is running. So it is basically dependent on the operating system that we are using. It will match the graphical designs of the operating system that we are using. Considered to be heavyweight components using native GUI system elements. We have another API, that is the Swing API, and that is comparatively newer than the AWT API. And apart from these two, we have the JavaFX API as well that we can use, but in this course we will focus on the Swing API. But Swing API is dependent on the AWT API, so we'll also look at the AWT, but we will be doing most of our applications using the Swing API. The Swing API has newer version of the components. No prior architecture, for example, components draw themselves. It does not depend on the operating system that we are using. It is independent of the operating system. Most are considered to be lightweight that do not rely on the native GUI or operating system. So it will be comparatively lighter than the AWT library. Abstract Windows Toolkit provides basic user interface components. For example, buttons, list, menus, text fields, etc. Event handling mechanism organize components using layout managers. The Swing API, a newer library written from the ground up that allows much more powerful graphics and GUI construction. Swing component names begin with J, and we'll see that when we develop our programs using Swing library. Component AWT versus J component and Swing, so that we call it a component in AWT, but we will call it J component in Swing. Always use Swing components as we will be using most of the times. However, since Swing is built on top of AWT, you will need to know some AWT methods as well. The elements of the GUI, as we understand it, is Windows. We have been using the GUI based operating systems, and we can see that it is mostly based on the Windows. Actual first class citizens of desktop, also called top level containers, examples or frames or dialog boxes. So we built things into the windows that are provided to us on the screen. And those things are the components that can be added to the windows, and these can, for example, include GUI widgets, let's say buttons, text boxes, labels, etc. Containers are logical grouping of components. For example, panel. For example, you want to group certain text boxes or buttons together. Then we can draw a panel on the form or the window and group those components together. You can see it in this example and this window. So if we call this whole thing our window, this will be our form. Then we can see that these are the labels. This is the text box. This is a button, a JText field, J button. These are the default names for these, and this can be called the panel that contains these items. This whole thing is called the window that can contain the components. So whenever we use the word components, then we would mean the buttons or the labels or the text boxes that can be added to a window. And the containers would mean the forms or the panels that we add our components to, that can hold our components. So if you have a look at the hierarchy or the Swing component hierarchy, we can see that it is derived from the AWT component and the AWT containers, and then we can use the J components of the Swing library, which include button, J label, J menu bar, J option pane, J panel, J text area, J text field, and then we can have the frame from the AWT, and we can derive the J frame as a container. So the J frame will be our container where we can add our components. We'll be using most of these in the examples. in the upcoming lecture. Using J option pane, most applications use windows or dialog boxes, also called dialogues, to interact with the user. J option pane, for example, provides pre-built dialog boxes for input and output. Note, the user cannot interact with the rest of the application while dialog is displayed. And we will look at an example of J option pane as well. It can take input from the user and can provide the results on the screen, displayed via static J option pane methods. For example, we use two input dialogs to obtain integers from the user and a message dialog to display the sum of the integers the user enters. So we'll work on an example where we take input from the user, and we'll see how the J option pane works. And we will display the sum of those two integers to the user. So this can be an example. For example, the J option pane show input dialog. Now this method is used for, and this is a static method, we can call it with the class name J option pane. This method will display a message on the screen with a dialog box and a text box where we can enter our integer value. Then we will display another dialog box on the screen asking the user to enter the next integer. And we need to remember that all the input is in the text form. All the input that we provide through the dialog box or the text box will be in the text form. And we need to keep this in mind that whenever we are working with the integer values, we will need to convert those into the integer from the text format to be able to perform calculation on those numbers. So we convert our number 1 or num1, this variable that is in the form of string. We'll need to convert it into an integer and store it in an int, or we just only store the result. And this can be called typecasting, where we convert a string into an integer. And then we display the sum of the two numbers on the screen. J option pane dot show message dialog. The sum is, for example, will be displayed on the screen. Sum of two integers, J option pane, plain message will be displayed. We'll see what these arguments mean. This argument shows us the position of the dialog box on the screen. The null value will display the dialog box on the middle of the screen. And this argument shows the type of the message that we want to display on the screen. There can be another type of messages, for example, warning messages, there can be question marks. In this case, we are only displaying a plain message on the screen. So when we run the program, we'll get this dialog box on the screen. Enter first integer. Whatever integer value you provide, you click OK or press enter. Enter second integer, you will provide the second value. These will be converted into integers in the background, and we will get this on the screen once we have entered the value for both the numbers. We will look at this example in Java, how to create this example in Java. If you look at this code, we have imported the Java swing.j option pane into our program. You can find the all of these codes in your book in chapter 12, and this will be also provided to you for the sake of practice. So you have the first number, and it is in the form of string. Option pane dot show input dialog. Now this is for displaying the input dialog on the screen. This dialog box will take some input from the user, and the second one will take some input from the user as well. It will convert the two strings into numbers to be able to perform calculation on those numbers, and then it will display the output on the screen. Now we have seen what a J option pane will what kind of result or what kind of a dialog box a J option pane can produce on the screen. If you run the program, you can see that this is a result of the first statement in our program. J option pane show input dialog, enter first integer. This is the output of the first line. Once we have entered a number, we click OK. Then the second line executes and it is asking us to enter second integer. Once we have entered the second integer, you click OK. In the background, these two integers are converted into numbers and the sum of these two numbers is calculated and the sum of the two numbers is displayed. The show input dialog method that we just saw is a static method. Displays an input dialog using the method string argument as a prompt. The user types characters in the text field, then clicks OK or presses the enter key to submit the string to the program. Can input only strings, and we will need to convert those strings if we are working with numbers into int format or other format that we are working with. And this will be the case with most of the GUI components. If the user clicks cancel, returns null. Show message dialog, on the other hand, is a static method. It displays a message dialog on the screen. The first argument helps determine where to position the dialogues. That we saw was null in our case. That is the first argument that tells the compiler where to display the dialog box on our screen. If null, the dialog box is displayed at the center of our screen. The second argument is the message to display. The third argument is the string that should appear in the title bar at the top of the dialog box. The fourth argument is the type of message dialog to display. For example, we displayed the plain message dialog and it does not display an icon to the left of the message. There are other types of dialog boxes that we can display. For example, in the show message dialog, we can display an information message that will be displayed with an icon I. We can display a question message that will be displayed with an icon question mark. We can display a warning message that will be displayed with an icon warning. And we can display an error message that will be displayed with the error icon. Icons, messages and OK buttons. J option pane show confirm dialog, frame, message title, J option, yes no option. So you can choose the type of the option that you want to display on the screen. Show confirm dialog is another method. Ask a confirming question, yes, no, cancel. Icons, messages, buttons, OK, cancel, yes, no, cancel. These are the options that we can choose from and display on the screen based on our requirement. J option pane show message dialog, frame is the position of the dialog that we want to display. Message is the message that we want to display. Title of that is will be written on the top of the dialog. And this is the type of the message that we want to display on the screen. In this case, it will be this message that is displayed on the screen. So these are the options that we can choose from, or the dialogues that we can display from. This is the yes no message, a yes no option. For example, the output of this code. You can try all of these codes in your program and you will see the results instantly. So this is the OK cancel option with the show confirm dialog, with the show yes no cancel option with the show confirm dialog method. Now let's look at some of the classes that we'll be using while working with the graphical user interfaces. and one of those classes is JColorChooser class. The JColorChooser provides a pane of controls designed to allow a user to manipulate and select a color. So it provides us with a dialog box that allows us to choose a color from. Maybe you have used some programs that allows you to choose a color from. So we have a show dialog static method. Arguments include the parent component title, that is string, the title string, and initially selected color or default color that is already selected. The user selects a color and clicks OK. Submit the selected color to the program. If the user clicks cancel, returns null. This is the type of dialog box that you can create with this line of code. So you create an object of the color class. We'll be looking at the color class as well. You create an object of the color class. You create a dialog box using jColorChooser.showDialog by calling the showDialog method. And this is the message that will be displayed on top of the title bar. On the title bar, the null is the position of the dialog box that you want to display, and the default blue is the default color that is chosen. You can choose any color from this pane that is provided over here. Another important class is the JFrame class. JFrame class is one of the most important classes that we'll be working with while we are working with the GUI components. JFrame is a window. It is a container that we can use to add other components to. A frame is a graphical window that can be used to hold other components. A JFrame object is a window with a border and a title bar. The visible area of a JFrame object is a container, which means that we will be able to add components such as JPanel object to the JFrame object. Note that components are added to the top of a lightweight container. It is called content pane. We'll see this is the content pane that we can add our other objects to. We can add components to this content pane. This will be the open area. It is like a canvas where we can add things. You can see this. This can be a canvas for us to draw things on, to add other components to. This whole is called the frame or the JFrame. This is the menu bar. You can create your menu on this area, and this will be the title of our JFrame. Most windows that can contain swing GUI components are instances of class JFrame or a subclass of JFrame. So most of the subcomponents that we will be using swing are either objects of the JFrame or subclasses of JFrame. So get content pane, we can add a label to this area by you calling this method. Labels or JLabel is again a class that we can use to add labels to our forms or frames. We can use it to add some text to our informative text on our frame. A text label is simply a string of text displayed on screen in a graphical program. Labels often give information or describe other components. JFrame, 4 important steps. Adding components. Set default close option. Set default close option allows us to choose what will be the default when we click the close button. It indicates that the program should terminate when the window is closed by the user. This is an important thing to choose. We should always have an escape point in our program that we can click on to get exit from our program, and this is provided by the set default close operation, and this will be used as an argument to close or terminate the window that we are using when we close the window. Set size or peg. Set size specifies the width and height of the window in pixels. Now initially we'll be using all of these methods and classes and through programming. Later on we will be using a drag and drop method of creating our graphical user interfaces, and we'll be looking at the properties that we can choose or set without using any code. But for the sake of our understanding, initially we'll be using a programming to set these properties and to create these objects. We can resize the frame to fit the components inside it. Set visible is an option that we can choose, that when we run the program we can choose to display or not display the window on the screen, or we can link it to any other button, that once we click that button and a certain JFrame should be displayed or it should disappear from the screen. So you have created an object of the JFrame class. Now the frame set default close operation, and this will tell the compiler to terminate the window when the user closes the window. And this is an important property to set to our frames, our JFrames. JLabel, we create an empty label and then we can add this label to. So we create a label object and we can then add this object to our frame using content pane, get content pane, and then adding the label to that pane. We can set the size of our frame. This will be the default size of our frame, and we can set the visibility of our frame as well. Once you run the program, this should be the output that you get on the screen. This frame will be displayed on the screen. This is the label that you have set the text to. So this is the label class, and the rest of it our JFrame. You can change the size of the frame and you can see how it affects your output. The JPanel class, we can create an object of the JPanel class within on our JFrame. You can use the new JPanel to create a panel for grouping components into a container, which can then be added to another container. And that other container can be our JFrame, and the components that we might group together can be the buttons or text boxes that we want to put together on our JFrame. Use the add component method to add a component to the panel. So we can use this method to add a component to our panel. We have initialized the panel, and then we can add components to the panel by calling the add method on that object. It is also a dedicated drawing area, so we override this method to specify how to draw. Call the superclass version of the paint component as the first statement in the body of the overridden method to ensure that the component displays correctly. We will see this in the example as well, that we will be calling the paint component method in the constructor of the panel to start our program.